Good morning, everyone. My name is Mansi Tripathi. I am TA for the course Water and Wastewater Treatment. So, we recorded, we did this week 7 before, but due to some error in the software, it was not recorded properly. So, I am recording it again for our own benefit. After that, I'll share the session with you all again. So, this will be a quick session and we'll go through all the questions. We'll try to solve some numericals as well as theoretical aspect, and then we can move forward with the further proceedings. It will be shared with you soon. So the first question is a numerical question which says, there is information about some community. We have the present population of 34,000. Expected population in 20 years is 52,000. Now we know the water consumption as well. This is regarding the present water consumption, that is 3,700 meter cube per day. And we have the water treatment plant design capacity. So we need to find out the number of years from now plant will reach its design capacity using arithmetic mean method. So as you know, there are various methods by which it can be calculated that how many what will be the further population. So here we are supposed to use arithmetic mean method of population. So there are basically many means to calculate the same. So first is if the city is very young, then we can go for geometric mean. Okay. And if the city is very old, it's a declining phase, so we can go with the declining rate of population growth. Similarly, the arithmetic mean will give us population in which the city is not saturated, but before saturation period, but it is older than the city having more growth opportunities. Okay, so here in such cases, we will apply arithmetic rate of population growth. So, in geometric mean, arithmetic mean, and increasing mean, arithmetic rate of population growth will give us the lowest value. Geometric mean population growth will give us the highest value, and incremental increase will give us values between both. So this is the question we need to solve. So we'll see in the next slide how it is solved. So as per the arithmetic increase method, Pn is equal to P naught plus Nx. X bar is the average. Okay, we will make a table. First of all, always while solving such questions, we will make a table very properly. One side will be year of population growth. Second will be population. And this part will be used when we are talking about incremental increase or the symmetric mean method. So the average we will find out here. Here we need to get the total as well as the average. Okay. So this is the average of the population for whole these many years. 52,000 minus 34,000 divided by 20. So we will get 900 per year. This is the average value. So design discharge to reach maximum capacity. 5600 minus 3700. This many design discharge we have extra till it reaches the maximum capacity. So present population consumption overhead is this much. This is how we are getting it. The present water demand divided by the present population. So this is what we are getting. Increase in consumption of water each year. This is the rate in which population is increasing. So this is the way in which the consumption will increase. So that is what we are getting, 92 meter cube per day. So hence the number of years to reach the design capacity is 1900. Oh, this is wrong. This will be 97.92. So this will be our answer. Okay, this is how this question will be done. Moving towards next question. Question 2 says, it's also numerical. Compute the fire demand. So there are various methods in which we can find out the fire demand. So this question is asking that for a city of 1.5 lakh population, we have to use this formula, American Insurance Association, or which is also called National Board of Fire Underwriters formula. So this National Board of Fire Underwriters formula is more common notion. So we have to deal with determine the fire demand in MLD. MLD is important here because in most of these formulas, the values are that we find are in either kiloliters or liters per minute. So we have to convert them into MLD, million liters per day. So we'll see how this formula, this question is solved. So first of all, we need to find out what is the equation of National Board of Fire Underwriter formula or American Insurance Association. So here Q is equal to 4637 under root P 1 minus 0.01 under root P. Here P is in terms of thousands. Here it's written, it is in terms of thousand. 1.5 lakhs means 150,000. Okay. And Q is the amount of water in liters per minute. We have to be very, very careful for this. Okay. So Q what we are getting is 4637 under root P 1 minus 0.01 under root P. So this is what we are getting, 71.763 mLD. This is value was given in liters per minute. Now we have to convert it into mLD because the question is asking in the same sense. That's why 71.673 mLD. Now the question number 3 is, if the average daily demand of the city, here this is the average daily demand, the maximum daily consumption will be. Here this is the average value, we are talking about the maximum value. So why there are so many demands like average, minimum, maximum, why? So mostly whenever we design any piped system or when we design the treatment plant for the water treatment, mostly we will deal with maximum daily consumption so that we can go on the conservative side. But when we design any secondary treatment, in which microorganisms are involved, we will go for average daily demand. Because if we design it in maximum sense, and if the water value or the organics are coming which are less, then the bacteria which are already acclimatized to the higher environment may die off. That is why in such cases, average demand is considered, but in most of the cases, maximum daily consumption is considered. However, when we design the pipes, okay, here maximum hourly consumption is considered. Okay. We'll see how this is solved. Very simple solution. We have to just multiply the average demand with some daily variation factor. So daily variation factor is 1.8. In such cases we have hourly variation factor also, monthly variation factor also. So Goodrich's formula is there, which will help us to find out what is the daily variation factor. I hope you have studied the Goodrich's formula. It will be better if you can say the formula in the next session. So this is question number 4. The table which I was talking about in the previous questions will be used here. The population of the town for 7 decades from 1941 to 2001 is given in the following table. So here you have to arrange it in the tabular form. If the water supply scheme must commence in 2006, so this is 2001, maybe the construction has been started and it will take 6 years to clear all the government regulation and starting of the plant. 2006 it is starting. So we have to estimate the population of 30 years hence, means from the starting to 30 years. 30 years is the design period. Okay. By incremental increase method. We don't want to be more conservative or pessimistic. So we are using incremental increase method. The population in thousand of the town for year 2036 is. This is the question. This is the year in population. We will first make it into tabular form. Year we have written, population we have written as it is. This is increment. What is increment? This is P1. This is P2. So increment is P2 minus P1. Okay. So whatever we are getting is I. Just say I1, I2. This is P3. So this is what? P3 minus P4. Okay, we are getting I2. So what will be this? Incremental increase Y. This will be I2 minus I1. We will put the signs. Whatever it is coming, we will keep on the signs. Here it is positive because 17,000 is obviously more than 4,000, and here it is negative because this difference is negative. So I2 means n plus 1 minus in. This will be there. So this is what we got. We will add this and divide by 1, 2, 3, 4, 5. So by 5 we will get x bar, average increment, and when we will add this with sign and divide it by 5, we will get y bar. Okay. So the total increase in population is 11,6,516. So what is x bar? As I told you, it will be divided by 6 because total number of those values were 6. So 119, 419. So total incremental increase is 2909 divided by 5. We will get y bar. Just now, from 2006 to 2036, how many decades are passed? 3.5. So we will just put these values here, and P naught will be the last population known. Just putting all these values and we will get the answer. Okay. This is how it is done. Be very careful while preparing the tables and all and calculations. This question will never go wrong. Next question is based on MPN technique. What is MPN? Multiple fermentation or maximum probable number techniques. So these are used to find out the number of microorganisms present in the water body, mostly pathogens. So we have taken a surface stream and we have done these tests. So what we have done, we have taken this. Normally what we do, we take 3 tubes, but here they have taken 4 denomination and 5 of each. 5 of each. And they have kept this much volume of sample, 1.1, 0.01 and 0.001. And they have calculated out of 5, how many of them are showing bubble. How this bubble is calculated? In this solution, we put a diagram tube inverted, and we try to see the bubble here. If the bubble is there, we consider them as positive. If the bubble is not there, we consider them as negative. So we have just kept it like this, and we have noted the number of positives and the number of negatives in each denomination out of 5. Then after that, there are many methods to calculate the MPN. One is Thomas coefficient. When the MPN table is not given, you can use the Thomas coefficient. Otherwise, normally we use MPN table. In MPN table, we talk about these 3 denominations, 1 ml, 0.1 and 0.01. So, and if we will calculate first for these 3, then for these 3. Whatever this is giving us the maximum value to be on conservative side, we will use that value. Okay, this is how it's done. So for now, we will be using Thomas coefficient. The Thomas equation we are using, MPN for 100 ml is equal to number of positive tubes into 100, total number of positive tubes. ml of sample in negative tube and ml of sample in all tube under root, and these are in multiplication. So number of positive tubes was 4, 3, 4, 2 and 3. So 3, 4, 7, 8, 9. Okay. And number of ml in negative tubes, number of ml in all tubes. Just putting all these things, and this is the answer we got. This is 332 per 100 ml. Okay. Moving to our next question, this is theoretical question. So here we have to match the following treatment units with the function that they do. So we can, when we aerate the sample, so here you can see when we aerate the sample, we this color, odor and taste will be reduced. Softening means removal of hardness. What is coagulation and filtration? Coagulation means it removes the suspended particles and filtration removes the colloidal dissolved and bacteria. Moving towards next question. Select the correct statement regarding coagulation. So, alum coagulation produces aluminum hydroxide block in the coagulation process. This is very correct. Alum coagulation decreases pH in the water. Yes, it consumes alkalinity, so it decreases the pH. The zeta potential of particle is increased during coagulation. No, we try to decrease the zeta potential so that the particle can come closer. The correct sequence of treatment of a typical turbid wastewater treatment is coagulation, flocculation, sedimentation, and filtration. So, these are the correct answers. Okay, except for C. Actually, what happens? Zeta potential is reduced. Coming to next question. Okay, match the following plants points marked on the graph with the concentration given below with respect to effect of concentration of electrical double layer. So when this coagulation process happens, the electrical double layer will be formed. So we try to reduce the zeta potential only. So means we try to reduce the width of the electrical double layer. So we keep on putting some alkaline, some ions so that this difference can be increased or decreased. So here we are putting these three. So we'll see the answers. So answer is C. 2 means here the least number, more the number of anions, more the number of ions, lesser is the distance, means the width of the electrical double layer. Okay. So we put more ions to suppress the formation of the double layer. In a water treatment plant, the